Right, so first thing we're going to look at just kind of some basics with algebra stuff, not even stuff that's in the book, just kind of a review. As I said, I'm going to try to get through it today, whatever we have time for tomorrow and Friday, and then no homework as long as we can get through what we got to get through. All right, so first thing on your guided notes says a blank is a symbol used to represent an unknown quantity. Does anybody know what that is? What word I'm thinking of? Yep, and I need to try to learn some names. So we've got Olivia?
Variable?
Yeah, a variable. So in that first blank, you don't have to write the whole definition. That's already written for you. You got to fill in one word. A variable. So somebody give me an example of a variable. What's an example? You got a spot on your worksheet that says examples, and you could write down whatever ones we come up with. Someone give me an example? Yeah. Is it Aileen?
Yes.
Yep.
Isn't it like the letters?
Sure. So X. X is a variable. Yep. Y is a variable. M is a variable. Okay. Z. Any letter. Now, if we're doing a word problem, sometimes you pick the letter that goes with the problem. Like if the question was how many balloons, maybe you'd use B for balloons. But X and Y are ones that we use a lot, okay, especially when we get into like graphing. Has anyone heard Y equals MX plus B?
Yeah.
Yeah, we're going to spend a ton of time on that way later. Probably like October, November. But that's why I want to do that test too, because if you've already done all that, it's going to be kind of boring, kind of repetitive. So we'll see where you're at with the pre-test, and if you get 100 on it, I'll just say to you, maybe you want to talk to your guidance counselor and say, well, I kind of did some of this last year, because if you're in this class this year, it's kind of hard to switch next year because this is only the first half of Algebra 1, so you can't switch to geometry until you've had all of Algebra 1. So unless you take all of Algebra 1 this year, you can't do geometry next year. So it's kind of like if you think you're in the wrong spot, we want to figure that out pretty early. All right, this next one is a little harder. It's 2 words. And blank blank contains one or more variables and usually one or more operations. That's an algebraic expression. Did you know that one?
Yeah.
Oh, you did? Okay.
Joe is very smart.
No, don't say that.
All right, I'll go with you next time, Joe. So an algebraic expression. So an example, it says, let's read what it says again. Contains one or more variables. So it could actually just be a variable. Okay. X, that's an algebraic expression. It's a very, very simple one, but usually it has one or more operations. Now when we say an operation in math, we're not doing heart surgery. What do we mean by an operation? Like there's 4 simple ones.
Yeah, like X plus 28.
Plus, that's one, yeah. Add, subtract, multiply, divide. That's operations. Okay. Exponents. If you're not sure what an exponent is, we'll talk about it, but that's an exponent. And notice there's a number right next to that letter. 2x squared. I'm just writing it bigger. What does this mean when we put a number next to a letter? It does mean an operation.
I'm trying to think of the name.
What does it mean? Yeah.
It's like when you times it and then you put it to the second power.
Yeah, well right here is exactly right.
Times 2.
Times it. Okay, there's an invisible times symbol. We don't usually use X for times in algebra because the X symbol for multiplication can look like a letter, so we don't do that. But we can use a dot. So when you put a number next to a letter, that means multiplication. I think this is one that Joe kind of gave us. He said plus. That's another algebraic expression. You can't solve it. You can't say, well, what is y? Well, y could be anything. You can't solve something unless it has an equal sign. Okay? These are just expressions. Expressions, very, very simple. They're not equations. Equations are a little more complicated. This is an equation. Now that's a problem you can go ahead and solve. Okay? Here's another one. 8x minus 3y. Again, not an equation. It's just an expression. If I put equals and then a number in there, boom, now it's an equation. Okay? So algebraic expressions just have letters, numbers, and sometimes they have a symbol like add, subtract, multiply, divide. Now, evaluate. Okay, that's the next thing. When you anyone think they know what does it mean to evaluate? Like if you had to explain it really simple to someone. If I said evaluate this expression right here when y is 4, what would you do? Yep, James?
Go into more depth.
Okay. Can you go into more depth? Like if I said evaluate when y is 4, what would the person have to do?
Say like maybe 5 plus 4.
So what did you
Y
do
is
to the...
equal to-
Yeah, you plugged in a number for the letter. Exactly. So the next thing has 3 blanks. To evaluate an expression means you plug in a number for the letter. What number? Whatever number they tell you. Okay? They'll tell you the number to plug in. And evaluate means you're usually looking for a numerical answer. What does that mean? If an answer is numerical, what is it? Think about, like if you plug 4 in for y, 5 plus 4 gives you what? How much?
9.
9. And 9 is a what?
Number.
It's a number. Right? That's what numeric means. It means it's a number. So when they ask you to evaluate, you're looking for a number. Like if I said, evaluate this when x is 5. Okay? You take and you plug in a number for the letter and you see what you get. And you write down your answer. Okay? So evaluate means to find the number answer. All right. So let's try and evaluate. Okay, so this says evaluate the expression 2xy. Now, I don't see any plus signs or minus signs or division signs or multiplication. So how do I know what's going on here? 2xy, what, is it addition? What is that?
Maybe multiplication because they're like touching.
Right, they're right next to each other. So some people might write it this way. That's the same thing. 2 times x times y. Does anybody know one other symbol you can use for multiplication? Yeah?
Parentheses.
You can use parentheses. I think this makes it look more complicated. There's nothing wrong with that. But this is the simplest way to write 2xy. How many different variables do we have right there? Yeah. 2. And it's telling you to plug in a certain number for x and a certain number for y. What number is it telling me to plug in for the x? Joe?
4.
4. So we're going to plug in a 4. And what number is it telling me to plug in for y? Maya?
3.
Yep, good job. We're going to plug in a 3. So when I rewrite it, I've got my 2. Now I got to be careful. If I plug it in now, we're plugging in 4 for x and 3 for y. That looks confusing to me. I mean, I changed the x to 4 and I changed the y to 3, but why do you think that would look confusing? Yeah?
Because if there's no signs to show that they're being multiplied, it'll look like just one big number.
Yeah, this just looks like the number 243, and that's definitely not the answer. It should be 2 times 4 times 3. So when you have numbers like that, and you want to show that they're multiplied, you can't put a number next to a number, like 5, 6. And have that mean multiplication. You can put a number next to a letter, that's okay. That means multiplication. But if you've got 2 numbers, you got to put a dot, or you could use parentheses. And now we're going to multiply, we're going to go over the order of operations in a second, but we just go left to right. 2 times 4, how about Blake?
8.
It's going to give me 8. I didn't do anything with the times 3 yet. That's just hanging out there. And Aileen, what's 8 times 3?
24.
There you go.
32.
That's 8 times 4.
Oh, there's a 16. Okay, 1 second. I'm not.
So any questions on what it means to evaluate? We're going to be doing that all year. Just plug a number in for the letter. How many of the letters? All of them. If there's an x and a y, you got to plug in for the x, whatever they tell you, and plug in the y, whatever they tell you. Does it make a difference which number you put where? Could it make a difference?
No. Yes.
Well, not in this one.
What do you mean by that? Can you explain more? What do you mean by that?
So, like, let's say if I accidentally put in 3 for x and I accidentally put in 4 for y, I would have this, which in this case is the same. All right? But if you had something like, let's go 2x plus 3y. Now, which one you put where makes a difference. If you put in 4 for x, 2 times 4 is 8. And if you plug in 3 for y, 3 times 3 is how much? You get 8 plus 9, which is 17. Now, if you accidentally switch the x and the y, you're not going to get the same answer. Let's accidentally plug in 3 for the x. 2 times 3 is 6. Now let's plug in 4 for the y. This is wrong. We made a mistake. If you plug in 4 for the y, you get 3 times 4 is 12. Is 6 plus 12 17? No. So if you put the numbers in the wrong spots for the wrong letters, it can mess it up. So make sure you put the x where the x is supposed to be for 4. And if it says y is 3, make sure you put the y in as 3. All right, so we've got 4 basic operations in math. Add, subtract, multiply, divide. And in fact, what I just said to you is some of what you're going to put right here. But there's other ways to say add. Somebody tell me another way that you can say add. Like what's another way you could pronounce that? Yep.
Plus.
Plus. So the word plus means to add. What about another word? Do you know what you call it when you add 2 numbers together? It's the, like if I had 5 plus 6, that's 11. 11 is the sum. Okay, so there's a lot of different words. We got some of them. We got plus. I said added. I said sum. Increased by. We didn't say that one. So like if I said to you, the temperature now increased by 5 degrees from what it was this morning. So yeah, if I said the temperature now is increased by 5 degrees. So if you, from what it was like at 6 a.m., you could say, okay, well the temperature at 6 a.m. was 60, and if it went up 5 degrees, increased 5 degrees, that means add 5. So now it's 65, okay, something like that. Plus added to more than. So like if somebody had, let's say Lucas had $15, and I said, well, I have $2 more than him. Well, that just means to add 2, right? And you know how much I have. $2 more than Lucas, I have 17. So more than is another way to say add. How about this next one? What's a way you can say that one? Yeah?
Minus.
Minus, yep, that's one way.
Decrease.
Decreased by, that's kind of the opposite of all the ones up above. Yep.
Less than.
Less than, yep. All these different ways. Minus, subtracted, we didn't say that one, I don't think. 42 minus x. Minus can be a little tricky because the order is important. That's what I'm putting with this little arrow right here. So, putting a box around this one, because that one is kind of special. Putting a box around this one. And the other ones are okay. The reason I put boxes around them is because look at what's in the box. The x comes first, and the 42 comes second, if you just read it. Well, that's not necessarily how you would write it. Okay? Like if I said to you, let's say, somebody tell me the answer to this problem. What is 2 less than 10? What's 2 less than 10, Patriot? 8. So to get 8, think of what I said. 2 less than 10. Would you do 2 minus 10? Would that give you 8? No. When you think about 2 less than 10, it's actually 10 minus 2. The thing at the end minus the thing at the beginning. So with subtraction, sometimes the phrasing is a little weird. Okay? So with the ones with the boxes around them, if you use the phrase less than, if you use the phrase subtracted from, the order matters and you write the second thing first. If you say minus, no, that's just normal. 12 minus 5. You write it exactly in that order. 12 minus 5. 10 decreased by 7. 10 minus 7. Goes right in that order. Just the two with the boxes are a little weird. All right. How about this one? We've already done a couple of these. What's a couple ways you could say 16x? That operation. Yep, Maya? Multiply. Yep. What else? Yep, Joe?
16 times x.
Times, yep. Multiply, times. What do you call it when you multiply two numbers? It's not like the sum or the difference. It's the... You want to know that one? Yeah. Product. Good. So we had times, we had multiplied, we had product. I think we got them all. So all different ways to say the same thing. And how about the last one? What operation is that when you get a fraction?
Divide.
Yeah, divide. So there's a few different ways to say that one. Divide, not as many, but divide and quotient. How many people have heard that word quotient before? It's not used as much. Yeah. Right, so what we're going to look at now is I'm going to give you guys a sentence. And I just want you to change it from an English sentence into something that looks like math. Okay? So example 2, there's a spot right next to it. You can write the directions. We're going to write an algebraic expression for each word description, okay, or each sentence. I'm going to give you guys a second to copy that.
Mathematicians are so weird because no one's going to buy like a bunch of pounds of tomatoes.
Well, they might not buy it, but that's maybe what they would, like if you said,
Bobby goes to buy
Yeah.
70 pineapples from the store. No one buys 70 pineapples.
they're probably not going to buy 70, unless they got like a luau or something. So for here, I just kind of want you to think of the operation. Okay? If you buy P pounds and every pound you buy is 79 cents. Okay? Would you involve addition, subtraction, multiplication, or division? You buy P pounds and every pound you buy costs another 79 cents. Yeah, Kate?
79p.
Yeah, exactly. It's 79p. That's it. Why is it multiplication? Because for every pound you buy, it's another 79 cents. Same thing with like gasoline. If you said, well, gas is, just to be simple, it's a little cheaper than this, $3 a gallon. And I buy 2 gallons. I'd say, okay, 3 times 2. If I bought 10 gallons of gasoline, and it was $3 for every gallon, I have to multiply how many gallons I bought times how much each gallon cost. 3 times 10, whatever I said. So I just wanted people to see that that's multiplication. How about this one? I'm not worried about the order yet. I just want to know what operation. Y years less than X years. what operation are we going to use? Joe?
Minus X.
Okay, I agree with minus. Now, sometimes what I do when I look at it, if the letters look confusing to me, I think of it in terms of numbers. So let's just think of it as 2 less than 10. Whether it's years, two pineapples less than 10 pineapples, it doesn't matter. How would you write, start with the one on the right, how would you write 2 less than 10? What minus what? Yep.
10 minus 2.
You would write 10 minus 2. Whenever you see the word less than, you always write the second thing first. That's just how it works. 2 less than 10 means 10 minus 2. So now let's go back here. Y less than x. We're just basically replacing 10 and 2 with y and x. So what do we have there?
X minus y.
Yes. Yep.
Could it be the other one?
No, it can't be the other way, because think about, like, if you did 2 less than 10, if you switch it like this, you get a different answer. Yeah, you get the opposite. So if you accidentally switch it with subtraction, you would get the opposite. With addition, it wouldn't matter. If I said 10 plus 2 or 2 plus 10, same thing. But with subtraction, it makes a difference. Any question on that? Yeah.
So the order, why can't we just write it like y minus x and just get a negative? What's the order thing?
Because when you say less than, you always have to put the second thing first. Like if I said to you, your age, like if I said to you, you are 2 less than, I don't know, are you 15? 14, 15? Turning 50, let's just say you're 15. So if I said, you are 2 less than 17, right? If I say 2 less than 17, that doesn't mean you're turning negative 15 years old.
Okay.
I gotta put it in that other order, otherwise I have the wrong sign. Yeah. How about this one? Increased by. What operation are we going to use with increased?
Addition.
That's addition. And with addition, it doesn't really matter. You can put it in any order you want. I just put it in the order I see it. X increased by 14. X plus 14. Could you do 14 plus X? Sure. Same thing. Any questions on that? All right, so last thing we're going to look at, and we'll do as much as we can. I'm not sure. We might finish. We might not. But whatever we don't finish, we'll finish tomorrow or Friday. Is anytime we perform arithmetic, okay? Doing arithmetic is different than solving an equation, okay? This is totally different from this. Two different sets of orders of operation. We're looking at the one on the right. Does anybody know the name that we're looking for to follow? I may have said it earlier. Order of operations?
PEMDAS.
PEMDAS. Yep. So when we perform arithmetic calculations, we follow an order of operations. PEMDAS is a word or an acronym that we can use to remember what order to do things in. Okay? And most of this, you already have all the blanks here. You just have to write PEMDAS going down the left. And when we get to the M and the D and the A and the S, I'll explain what those two mean. All right, so what does P stand for? Yep, cadence.
Parentheses or brackets.
Yeah. Parentheses, brackets, means the same thing. Basically, those are both examples of a grouping symbol. Something that wraps around stuff. Okay, so anytime we're doing arithmetic, always look for your parentheses first and do what's inside. Yeah, I won't spend forever on it because I'm sure everybody's already done that. How about E? What does E stand for again?
Exponents.
Exponents. How do you know something is an exponent? We actually had one earlier today. You know when a problem has an exponent in it.
Oh.
Yeah.
Like the number is really like smaller in the corner.
It's smaller in the corner, it's like up a little higher. It's like an exponent. Might look like that, 3x squared. It's up a little bit higher than everything else. So next thing you always look for is exponents. How about M? We're getting into our 4 operations that we just talked about. Yeah, how about Lucas?
Multiply.
Multiply. And the operation that goes with multiplication, because it's the opposite of it, is division. I'm not saying that you always do multiplication before division here. I'm saying you do these two in order, left to right. So like if I had a problem like 5 divided by 10 times 2. I don't do 10 times 2 first. I do 5 divided by 10 first. So if you want to think of like which operations are in control, parentheses are in the most control. They say, get out of the way, you got to do me first. And then exponents, they're like the second ones in control. They say, all right, now you got to take care of me. Multiplication and division, they're equal. You don't have to do one before the other. You just do them in order, left to right. And it's the same with the last two. What are my last two? Yeah.
Addition.
Yep. And my last one?
Subtraction.
Subtraction. So with addition and subtraction, you don't necessarily do addition first. You do whichever one you see in order from left to right. So we're going to finish with example 4. That'll be the last one we look at today. And then that doesn't leave much next time. We only have examples 5 and 6. So there's only 2 more. Okay, so hang on to this. Don't lose this because we're going to use it again next time. All right. So that's the problem we're going to simplify. Okay. Simplify just means do as much as you can with PEMDAS. Okay, so what does the P stand for again? Parentheses. Do I have any parentheses here?
Yes.
Yeah. I see some other stuff in the top like exponents, but for now, I don't want to do anything in the top. Okay, I'm going to hold off on that. So I'm just going to copy the top over. I'm not changing anything. But what can I do in the bottom? What would be my first step there? Yeah, what calculation?
5 minus 3.
Good job. We're going to do 5 minus 3, which is how much? 2. This other 2 on the outside is an exponent. It just stays there. Only thing I did was 5 minus 3. Do I have any other parentheses? Nope. What do I have a lot of next? Tons of them, all over the place.
Exponents.
Exponents. We're going to do them all. Okay, we're just going to go right in order and do them all. 2 to the 3rd power. Okay, another way to say that is 2 cubed. What does 2 to the 3rd power mean? What times what times what? Yeah.
2 times 2 times 2.
Yeah, 2 times 2 times 2, which is how much?
8.
8. Good job. So we did the first one. 4 to the 2nd power. 4 squared means 4 times 4, which, how much is that one? Yeah.
16.
Good job. 16. And the last one, 2 to the 2nd power means 2 times 2, which is how much? Yeah, 4. Nice. Good job. So we did that. Now, one thing that can be a little bit special sometimes is when you have a fraction, right? I have to kind of combine what's in the top here before I can really go any further. right? So when we combine 8 plus 16, what do you get? How much? Yeah.
24.
24. Nice. You can kind of think of a fraction bar as a grouping symbol. You have to simplify the top all together and the bottom all together.
I apologize for the interruption. The next bell, just a reminder, freshmen will be heading to lunch.
And now we're at the last step of this fraction, which is basically to reduce it. What's 24 divided by 4? 6. Nice job. So again, there's no homework tonight. Hang on to this worksheet, and we will finish up tomorrow.